This video is on composite transformations. The definition of composite transformations is when you have multiple transformations done on a figure. When you do multiple transformations, you start with the pre-image of A. You do one transformation, which turns into A prime. You then do another transformation that could turn into A double prime. You could then do another transformation, which would turn into A triple prime. And you put the 3 tick marks. Then you could keep going, so you put etc. It would keep going. You call it prime, double prime, triple prime, and you would keep going. The thing about this is that you do not use coordinates of the pre-image again. What that means is that you actually use the pre-image to get your image. Then you use your image coordinates to get your double prime. Then you use your double prime to get your triple prime. You never go backwards. There are 2 composite theorems that are about reflections that I want to discuss in this video. A composite of reflections, so when you do multiple reflections, a composite of reflections in 2 parallel lines is actually just a translation. So if you reflect over 2 parallel lines, the end result was actually just a translation from your pre-image. So for an example, I'm going to draw 2 parallel lines as best as possible. I'm going to show that they're parallel by putting the symbol for parallel, so a little triangle, or it could be a little arrow on it, but the same amount of triangles tell us that these lines are parallel to each other. So if I call these lines L and M, I use a lowercase cursive letter to name my lines. If I have my pre-image, let's say I just have a triangle, I'm going to make it kind of noticeable that the lines are different. I'm going to use just one letter right now and call that A. If I were to reflect this triangle over the line L, and I'll make this into a green figure, I know that reflection is just counting away from the line of reflection. So I can see that this coordinate right here is pretty close to the line of reflection. So I'll do like 1 away for that point. I'll do the same 1 away for this point. Then I have this third point is about 1, 2, 3 away. So 1, 2, 3 away. Something like this. Obviously, it's not going to be exactly perfect because I'm not doing it on a coordinate plane, but I'm doing a rough sketch of it. So this would be A prime because that's my first transformation. Then I want to take my image, my A prime, and reflect it over the line M. So I have a composite transformation, and I'll do this in red. Now I want to go from A prime to the line of reflection, and then go from my line of reflection the same amount. So I know I'm going to the right, and I'm going to keep going to the right about the same amount. So I'm going to try and get it as close as possible. And again, it's a sketch, so I just need to make sure I'm at least close to the original, to the amount. So I know my second coordinate will do the same thing. Go to the right and keep moving to the right. Then my third coordinate is actually shorter, so it's going to be to the right, but not as far. And again, if I had it on a coordinate plane, I could easily count and have those done. Now, with reflections, I reflected it across the vertical lines, so I know I'm moving my x's. That means my A prime, and A double prime will actually stay up top. Now, we reflected it over 2 parallel lines. My pre-image of A, which is blue, went to my double prime, my final image, which is red. And as you can see, from blue to red, it just slid over to the right. A translation is a slide. It's when it changes position, but not orientation. So the blue did move over to the right to become red, but it's still pointing in the same direction. I still have my right angle down the bottom right, and same here. I have my A and my A double prime at the top, and I can see that my hypotenuse is going from the top down left. Top down left. I can see that that is just a slide. So I could have actually said that my final rule would have been moving my blue right until I got to the red. The second theorem for composite of reflections is when a composite of reflections into intersecting lines. Intersecting lines is actually just a rotation. Now this could be on any type of intersecting lines, but for this case, my example I'm going to show, I'm going to do it over the x and y axis because those are going to be the perpendicular lines. So if I have my x and y axis, I'm going to draw, I have perpendicular, these are perpendicular lines, so they are intersecting. Again, I'm going to start with my pre-image. I'm actually going to start it up in quadrant 2. And kind of draw it the same way I did before. Right triangle, try and make them slightly different so I can see that my bottom base is smaller or shorter. Start with A. And this time I'm going to reflect this pre-image across the x-axis. So I'm going to make it go down. So my y values will change. So I know this coordinate right here is really close to the x-axis. So I'm going to come down a little bit from the x-axis. Count down, count down. From A, I'm going to count down. I'm going to count down even further. So this is roughly the reflection of my pre-image. So I would call this A prime. This coordinate was A prime. Now I want to reflect it over another line, so it's the intersecting lines. So x's, I just reflected over the x, now I want to reflect it over the y. So this time, I'm going to have it in red. I'm going to reflect over the y, so I'm going to count to the right, and I'm going to count to the right. I'm going to count to the right, I'm going to count to the right. Count to the right, count to the right. And again, this is just a sketch, it won't be exactly perfect. I can connect my dots. And I would call this coordinate, because this is, I got A prime to come to here. This would be our A double prime. So from blue to red, I moved over 2 quadrants. And if I actually had the coordinates, let's say this is at -1, +4, rotating, potentially this could be 180 degrees. So again, this was at maybe -1, +4. A would be. So at A prime, this would be at +1, -4. It looks like it would be in around that location. So rotating 180 degrees is when you just negate the numbers. You change the signs. So a negative becomes a positive, and a positive becomes a negative. So that's 180 degrees. So again, when you reflect over 2 parallel lines, so from A to A double prime, is actually just a translation. It's just sliding it. When you reflect a pre-image around 2 intersecting lines, it is a rotation. So from A to A double prime is a rotation. Now this one, because it's over the x and y axis, this will actually be a rotation of 180 degrees. So that actually would help us. Instead of having to know the rule, we could actually do the reflection, and it would be a 180 degree rotation. If it's on any other intersecting lines, it would not have that very specific 90 degree, 180 degree rotation. It would just be a different type of degree. These are the 2 composite theorems that could be used to shorten actual composites, or to shorten a rule.